Okay, this is the P3 paper from June 2021. It's question number 8, which is an exponential modelling question, as we can see by looking at it. A little bit later on, there's some differentiation work, and that involves the quotient rule, and there'll be exponentials and logs all the way through it when we're doing the question. Okay, it's, what's that, 6, 9, 13 mark question, so there's going to be a lot of different parts to it. Let's make a start and see how we get on. First part says, scientists are studying population of fish in a lake, n's the number of fish, and what's t? It's years after the start of the study. Okay, so n is given by that complicated function there. And part A, a fairly standard thing, find the number of fish at the start of the study. So the start of the study just means t equals 0. So A, what have we got? We've got n is equal to 600e to the 0.3t over 2 plus e to the 0.3t. A relatively standard sort of function that they give us. They're always going to be not particularly nice to work with. But for part A, as I said, we're saying t equals 0. So we get n equals 600 e to the 0 over 2 plus e to the 0. And e to the 0 is 1, isn't it? So it's 600 over 3, so that works out to be equal to 200. So for part A, number of fish at the start of the study is n equals 200. Find the upper limit of the number of fish in the lake. Again, it's only worth 1 mark here, so it needs to be something that we can do quite quickly. The way that I approach these, other people might do them in a different way, but I basically say t tends towards infinity. So if t tends towards infinity, I'm going to make t equal to infinity and see what we get. So we get e to the 0.3, well, let's write it all out, 0.3 infinity all over 2 plus e to the 0.3 infinity there. So I say it's quite quick, it's only worth 1 mark. So the way that I do that is I think that that's 600 e to the 0.3 infinity, e to the infinity is infinity. All divided by 2 added on to infinity still just leaves me with infinity there. The 2 makes no difference at all. And then you can cancel those 2 out. So we get that n equals 600 as it tends towards infinity. Quite a nice, easy little method that I always employ for one of those types of questions. Okay, part C. Find the time after the start of the study when there are predicted to be 500 fish. Okay, so we knew we were going to have something like this. What we're basically doing is we're now saying that my function, 600e to the 0.3t over 2 plus e to the 0.3t, we're going to set that equal to 500, and now what we're going to try and do is work out t. So in other words, we need to just rearrange this formula to make t the subject of the formula. So let's get started with it. The first part is basic algebra. Take this over to the other side and multiply it up. Is going to give me 500 times 2 plus e to the 0.3t. And what I want to do is get e to the 0.3t on its own on one side. So that means multiplying out that bracket. So not changing that bit, but this is 1,000 plus 500 e to the 0.3t. I'm going to take that over to the other side now. So 600 minus 500 gives me 100 e to the 0.3t is equal to 1,000, which means that e to the 0.3t is equal to, that just comes down the 100, so 1,000 divided by 100 gives me 10. And I was trying to get to that sort of stage where I'd isolated e on its own there, because now I can take logs. Don't try and take logs any quicker than that. If we log both sides, then what we'll do is we'll get 0.3t is equal to log 10. So t is equal to log 10 divided by 0.3. And when we do that and we get the answer, let's just do that, log 10 divided by 0.3, that comes out to be 7 point, sorry, let me just do that again, log 10 divided by 0.3, that comes out to be 7.675. And you go back and you check what does it say about decimal places, significant figures. It doesn't. It says in years and months. So we just need to make sure that 0.675, change that into months, and it works out to be 7 years, 8 months. Be really careful on these sorts of questions. Time is often one of those things that they can mess around with us, and we'll lose one of our marks. Part C is only worth 4. I don't want to lose one of it by not following through what they're asking us to do. So part D now says show that the differential is equal to that. Right, fine. Okay, it just means I've got to differentiate my n now, which is just going to take a little bit of time. This is question number 8 of a P3 paper. It's okay that at this sort of stage we're going to get something relatively complicated to do, complicated algebraically anyway. E to the 0.3t all over 2 plus e to the 0.3t, and I'm just going to use the quotient rule on it. So I'm going to set u to be equal to the numerator, and so du by dt, this is just an exponential. Okay, if it's just an exponential, then we just multiply it by the 0.3. In effect, we're going to get 180 e to the 0.3t. Hopefully that doesn't cause you any problems. Same with the other one. We're going to have 2 plus, 2 plus e to the 0.3t, and I want to get dv by dt. The 2 goes, and the 0.3t becomes 0.3 e to the 0.3t. None of those should have caused you any problems, and so dn by dt is going to be, well, the quotient rule is v du minus u dv all over v squared. Right, subbing all that in. Now just be careful about this. Just take a little bit of time. We don't want to lose any marks. So v du is going to be these two times together, and I'm actually going to write that as 180 e to the 0.3t multiplied by my 2 plus e to the 0.3t minus, and then when I'm doing the other two, u dv dt, I'm going to do it slowly. Okay, so I'm actually going to do 600 e to the 0.3t multiplied by 0.3 e to the 0.3t all over, and then v squared is 2 plus e to the 0.3 t squared. So if we're doing that, let's multiply out this bit here. Let's just tidy that up. So I'm going to get, in fact, all of the numerator, when I'm multiplying all the numerator, so I'm going to do 180 times the 2, so that's going to give me, that's going to give me 360 e to the 0.3t. Then I've got 180 to 0.3t times 0.3t, so I'm going to write that as 180 e to the 0.3t squared, and then brilliantly minus, that actually cancels out, 180 e to the 0.3t squared all over, I'm just going to leave the denominator as it is just for a second, just while I'm tidying that bit up. Those two actually cancel each other out, so I end up with 360 e to the 0.3t all over 2 plus e to the 0.3t squared. Let's go back and see what we were trying to get, and it is that. Okay, it is that already. A works out to be 360. So absolutely delighted by that, with all the algebra involved in that we're actually able to then go ahead and still get that right. It's fab. Okay, and then where are we up to? Part E, given that t is equal to t when dn by dt equals 8, work out what t is to 1 decimal place. Right, so it's going to be another rearranging part, isn't it? So E, we've got that 8 is equal to this 360e to the 0.3 capital T over 2 plus e to the 0.3t squared. And it's just quadratic. You're just going to multiply it out and see what we get. It's up to you. What I did when I did this one was I just set u as being equal to u as being equal to e to the 0.3t, just to make it a bit easier when I'm actually going through and doing it. I'll just sub it back in at the end. So I've actually got 360u over 2 plus u squared, just because I then found that much easier to work with. So take the 2 plus u squared over to the other side. Multiply that all out. Now you can take as long as you want over this. I'm going to do it quickly. U squared plus 4u plus 4. So 8 lots of that is equal to 360u. Multiply that bracket out. Take the 360 over to the other side. This quadratic works out to be 8u squared minus 356u plus 32 equals 0. You can try and solve it by factorising if you want to. It probably does, but I'm just going to use the quadratic formula and stick it into the quadratic formula. So I'm going to get u works out to be equal to, and when you do that and tidy it all up, it all works out to be 41 plus or minus root 1665 over 2. You can tidy it all up and do that. We ignore the -1 because that doesn't give me a solution when I'm doing this last part. E to the 0.3t equals 41 plus root 1665 over 2. And all you now need to do is to rearrange and get t from that. Let's just quickly do it. So log both sides. And we get 0.3t equals the log of that bit there. And so then t just works out to be that divided by 0.3, which works out to be 12.4, correct to 1 decimal place. Whether you wanted to leave it and not do the substitution is entirely up to you. Then it would just look a little bit more complicated when you're trying to do that quadratic. But that question, yeah, lots of difficult algebra in there, but as I say, it is question number 8, and some good bits that you should be able to pick up some marks on, even if you can't get the whole question. But hopefully that makes sense now I've explained it.